All right, let's jump into this paper. How to probe. Simple yet effective techniques for improving post-hoc explanations.
Yeah,
It's all about explainable AI,
right.
which is already a pretty complex field.
Oh, absolutely.
But this paper adds like a whole new layer.
It really does.
So you sent this over to me.
Yeah, I did.
What is it about this that you find so fascinating?
Well, what I think is so interesting about this research is it challenges a fundamental assumption that we make a lot of times in XAI,
Right.
which is that, once we've trained a model,
Right.
that how we explain its decisions is separate.
Uh-huh.
But this paper shows how deeply intertwined those two things really are.
So we're not just talking about making the decision-making process transparent,
Right.
but also understanding like how the explanation itself is generated.
Exactly.
It's like we need a recipe for the recipe, so to speak.
Yeah, that's a great way to put it.
Okay.
It really is looking at how even subtle choices that we make during the training process can dramatically change the explanations that we get out of these models.
Huh. Okay, so walk me through this a little bit.
Yeah.
We're talking about pre-trained models, right?
Exactly.
The ones that are already good at recognizing patterns.
Yes. So think of these models as having like a vast library of knowledge
Okay.
that they've learned, but to apply that knowledge to a specific task, we use a probe.
Okay.
And so you can think of this probe as like a lens that focuses the model's attention on a particular problem, like identifying different bird species in images or something like that.
So it's like a specialist that kind of tailors that general knowledge to a very specific area.
Yeah, exactly.
Okay.
And so here's where it gets really interesting. The researchers found that even tiny tweaks to how we train that probe can lead to wildly different explanations for the model's decisions.
Whoa. So we could have two AIs,
Right.
both accurately identifying a bird species in an image, but giving completely different explanations for why they think it's that species.
Exactly.
All because of how the probe was trained.
Precisely.
That's crazy.
And it has huge implications for how we think about, interpreting and trusting these AI systems.
Okay.
And it really challenges this common assumption of post-hoc attribution methods,
Okay.
which are basically these techniques that we use after the model's already made a decision to try and understand what it's focusing on.
So are you saying that these post-hoc methods might be giving us misleading explanations
Potentially. Yeah.
if they don't account for how the probe was trained?
Yeah, that's a key takeaway from this research.
Wow.
That we can't just treat the training process and then the explanation process as separate.
Right.
They're fundamentally linked.
Right.
And ignoring that link could lead to, a false sense of understanding about what's going on.
Okay, now I'm really curious about like the specifics here.
Yeah.
What kind of tweaks during training are we talking about?
So one of the key things that they look at is the choice of loss function used during training.
Okay.
And this basically tells the AI how well it's doing and guides its learning process.
Okay.
And the paper compares two very common ones, cross-entropy, or CE, and binary cross-entropy, which is BCE.
And I'm guessing that they found that one of these loss functions produced like much better explanations than the other.
Yeah, they did.
Why?
They discovered that probes trained with BCE consistently provided clearer and more accurate explanations.
Huh.
They were better at pinpointing the specific features in an image that lead to a decision.
So is it almost like BCE is giving the AI like a more detailed report card?
That's a really helpful way to think about it,
Okay.
instead of just a letter grade.
Right.
So it learns to be more precise in its reasoning.
Okay.
And so, the nuances of that loss function really do directly impact how the probe learns to extract information from the pre-trained model and ultimately affects the quality of the explanations we get.
This is already pretty mind-blowing. But the paper goes even further, right?
They do.
Didn't they also experiment with different types of probes?
Yeah, so they compared simple linear probes with more complex ones called multilayer perceptrons, or MLPs.
MLPs, those sound pretty intense.
Yeah.
Are those the ones that are better at handling like really complex patterns?
Yeah, exactly.
Yeah, okay.
MLPs have a more intricate structure that allows them to capture those nonlinear relationships in the data.
Okay.
And the researchers found that those MLP probes, particularly when trained with BCE, were even better at extracting these class-specific features and providing, highly focused explanations.
So the more complex the probe and the better the training method.
Yeah.
The clearer the window into the AI's thinking thinking becomes.
Exactly.
This has got to be like a game changer for anybody trying to make AI more transparent.
Absolutely. It highlights this crucial aspect of XAI that often gets overlooked. We
Definitely.
can't just rely on the sophistication of our models or, our post-hoc explanation methods. We need to pay attention to the training process itself if we want to ensure that the explanations we're getting are actually accurate and reliable.
All right, let's pause here for a moment. I feel like we've uncovered a lot already, but I'm eager to hear more about how this research plays out in practice. We'll be back after a short break to dig deeper into the specifics and see what this all means for the future of explainable AI. Okay, so we've established that the training process can have like a huge impact on the explanations we get from AI.
Right.
But I'm curious, like, how do the researchers actually measure the quality of these explanations?
Right. It's not like the AI can just, tell us what it's thinking.
Exactly.
So they use something called the pointing game.
The pointing game.
Yeah.
Okay, I'm intrigued.
It's a way to test how well an explanation actually highlights the relevant parts of an image.
Okay, how does that work?
So imagine we show the AI a picture of a cat
Okay.
sitting in a tree.
Okay.
And the pointing game, we ask the AI to not only identify the cat, but to pinpoint the specific region in the image that made it think cat.
Oh, so it's not just about getting the right answer.
Right.
It's about showing its work, so to speak.
Exactly.
Right.
And so the researchers use this pointing game to compare the explanations generated by probes trained with different loss functions.
Okay.
Like the CE and BCE that we were talking about.
And I'm guessing the results showed that the BCE trained probes were much better pointers.
Yeah, they were much more precise.
Okay.
They consistently highlighted, the cat's ears or tail, the areas of the image that were relevant to the decision.
Right.
Whereas the CE trained probes often highlighted irrelevant areas like the tree branches or the background.
So even if an AI gets the answer right, the explanation it provides could be totally off base if it wasn't trained properly.
Exactly.
It's kind of unsettling.
It is a little bit, yeah.
It's like getting the right answer on a math test but showing the wrong work.
Right.
You might get lucky once, but it doesn't mean you understand the concept.
That's a great analogy.
Yeah, and this is why this research is so crucial. It shows that we can't just blindly accept the explanations provided by AI systems.
Yeah.
We need to understand how those explanations were generated and whether they're truly reflective of the AI's decision-making process.
Right.
This all feels a bit like detective work,
It really does.
trying to unravel the AI's thought process.
Absolutely.
And speaking of digging deeper, didn't the researchers also experiment with like more complex probes?
Yes, they did.
Not just those linear ones we talked about.
They went beyond those simple linear probes
Okay.
and explored using these multi-layer perceptrons, or MLPs.
MLPs, okay, those sound like they're something out of like a sci-fi movie.
I know.
What makes them so special?
So unlike linear probes, which can only capture, simple relationships, MLPs can model much more complex patterns.
Okay.
They're kind of like those super sleuth detectives who can spot the tiniest clues and connect seemingly unrelated dots.
So are you saying that MLPs could lead to even more insightful explanations?
Potentially, yeah.
Because they can delve deeper into the AI's reasoning.
Yeah, and the initial findings are really promising. They observed that those MLP probes, especially when trained with PCE, could extract even more fine-grained features from the data and provide even more focused explanations.
Wow, this is really opening up a whole new dimension of explainable AI.
It is.
It's like we're going from using a magnifying glass to a high-powered microscope to examine the AI's inner workings.
Yeah, I love that analogy.
It underscores the fact that explainable AI is not a one-size-fits-all solution.
Right.
We need a diverse toolkit of methods and approaches.
Yeah.
And this research is a significant step towards expanding that toolkit.
Absolutely.
This all makes perfect sense.
Yeah,
But it's a lot to take in.
I know.
I'm starting to see how this research really does change the way we should think about AI interpretability. But before we get too carried away, let's pause here for a moment. We'll be back after a short break to wrap up this fascinating deep dive and explore what these findings mean for the future of AI and for all of us who rely on these increasingly powerful technologies. All right, we're back. And I have to say, this deep dive has really opened my eyes to the complexities of explainable AI.
Yeah, it is a field that's constantly evolving, and, this research really shows that we're still just scratching the surface of what's possible.
It's striking to me that something as seemingly technical as the choice of a loss function
Right.
or the type of probe used
Yeah.
can have such a profound impact on the explanations that we get.
Right.
It's like we've been focusing on building these fancy cars, but neglecting the quality of the steering wheel.
That's a fantastic analogy, and it highlights a really crucial point. We can't just assume that our AI systems are inherently explainable.
Right.
We need to build explainability into the very fabric of these systems from the ground up.
So it's not just about having an AI that can perform a task, but about having an AI that can perform a task and tell us why and how it arrived at its decision in a way that makes sense to us humans.
Exactly. And this research provides, valuable insights into how we can actually achieve that.
Right.
By understanding the impact of these training choices on explanations, we can start to develop more robust and reliable methods for making AI transparent.
And that transparency is crucial, right?
Absolutely.
Especially as AI becomes more integrated into our lives,
Yeah.
in healthcare and finance, even self-driving cars.
Absolutely. We're entrusting these AI systems with increasingly important decisions.
Yeah.
And we need to be able to hold them accountable.
Right.
That means being able to understand how they work and why they make the choices they do.
It's like we're moving from a world where AI was this mysterious oracle,
Right.
dispensing pronouncements from behind a curtain,
Right.
to a world where we can actually peek behind the curtain and see the gears turning.
Yeah, I love that. And it really speaks to the potential of this research to empower us, to give us more control over these really powerful technologies.
Speaking of empowerment, what really struck me about this paper was the fact that the researchers actually made their code publicly available.
Yeah.
That's a huge step towards transparency in AI research, isn't it?
It's incredibly significant by sharing their code. The researchers are basically inviting the entire AI community to scrutinize their methods,
Right.
replicate their experiments, and build upon their findings.
It's like saying, hey, we're not just going to tell you what we did.
Right.
We're going to show you exactly how we did it.
Exactly.
That level of openness is essential for fostering trust and collaboration in the field.
Absolutely. It sets a really powerful precedent for other researchers.
Yeah.
And it encourages a more rigorous and transparent approach to AI development.
And that ultimately benefits everyone.
Exactly.
So as we wrap up this deep dive,
Yeah.
what's the one key takeaway you want our listeners to remember?
If I had to distill it down to one message, it would be this. Explainable AI is not an afterthought. It's not a box that we check after the fact.
Right.
It's a fundamental principle that needs to be embedded in every stage of AI development.
And this research gives us concrete ways to actually do that
Yeah.
by highlighting the importance of those training choices and advocating for transparency and open collaboration.
Right.
It's like a call to action for the entire AI community.
And for all of us who are impacted by these technologies, we need to stay informed. We need to ask these critical questions, and we need to demand accountability. The future of AI really depends on it.
Well said. This has been a truly illuminating deep dive, and I have a feeling we'll be revisiting these ideas many times in the future.
Me too. It's a conversation that's just getting started.
Thanks for joining me on this journey. And thanks to all of you listening out there. Until next time, keep exploring, keep questioning, and keep diving deep.
Bye.